Hello everyone. On behalf of the State Council of Science, Technology and Environment, Meghalaya, I welcome all the viewers to this online class that is conducted for you all, especially for the class 10 students. Today I will deliver a lecture on chapter 15 from Mathematics class 10. And today we will start this class. Let's begin. Before going into the chapter, first of all, we will try to understand the word probability. For this, I want to ask you a question. Suppose tomorrow you are planning to go for a trip somewhere, but you are not sure whether it will rain or will not rain tomorrow. So, will it rain tomorrow? You may say, yes, it will rain tomorrow because it's summer. But are you sure that it will rain tomorrow? You are not sure, right? But is there a chance that it will rain tomorrow? There's always a chance, right, that it will rain. So that word chance means probability. So probability and chance, they mean the same thing. So if you say there is a chance that it will rain tomorrow, in other words, we can say there is a probability that it will rain tomorrow. Let's take an example of a coin. A coin has two faces. Suppose you call this one face as head and the other face as tail. Then if you toss this coin up like this, then it will land. The top face will either show head or it will show tail. So we can say that there is a chance that will show head, and I can also say that there is a chance that will show tail. So in other words, we can say that there is a probability that head will appear on top or tail will appear on top. Now, in this chapter, before going into the exercise, we will first understand the important terms in this chapter. Now, we will take again the example of a die. A die is like a cube which has this mark 1, 2, 3, 4, 5 and 6 on the 6 faces. Suppose if you throw a die up like that, then the top face will either show 1, 2, 3, 4, 5 or 6. It will either show 1, 2, 3, 4, 5 or 6. See? It has only 6 faces. So it can show, if you toss this up like this, then the top face will either show only these numbers, right? It will not show any more other than these. So these numbers here of this, when you do this activity, means the activity of throwing a die. These numbers here, these 1, 2, 3, 4. These numbers, they are called outcomes. These numbers here are called outcomes of the activity, means activity of throwing a die. And these outcomes, suppose if you collect them in one set, and set we have a curly bracket, and then the members of this set we write here and we separate them by commas. This set S, it contains all the possible outcomes that you can get when you toss a dice once. So this set which contains all these outcomes of this activity of throwing a die is called a sample space of this activity. So this S is called sample space. Here when I said activity is a particular activity of throwing a die, but will be defined in general. And this element of this set, when we say element of this set, we mean members of this set. So the member of this set S, they are 1, 2, 3, 4, 5 and 6. So each of them element of S of is called a sample point. sample point of the activity. Now we will understand some more terms here. See. When I toss a die once, what will you? Can you predict that any of the face will appear on top? Can you predict? Suppose I toss once like this. Can you predict that one will appear or 6 or 5? You cannot predict, right? It's all random. So any of them can appear on top. So when we do this activity, any of them can appear on top. So this is like a random activity, right? So we call this activity of throwing a die, we call a random experiment. So I'll write down here. A random experiment. Now, suppose we are talking of a general random experiment. So here, if we say what is a random experiment, you just say that this activity of throwing a die is a random experiment because we cannot predict the outcomes. So in general, so that we get the definition from that only. So a random experiment is any experiment whose outcomes cannot be predicted in advance. Again, if you look at this example of tossing a die, so we cannot predict whether any face of this die will appear on top. Either 1 or 2, 3 or 4 or 5, 6, we cannot say. So it's all random, right? We cannot predict. So this activity of throwing a die is a random experiment. So in general, we can define random experiment as an experiment whose outcomes cannot be predicted in advance. And then now we will define what is a sample space for any random experiment. Suppose when you do this activity of throwing a coin also, so either we will get head or tail. So these are the only possible outcomes, right? Either head or tail. So in general also we can define a sample space as the set of all possible outcomes in a random experiment. So it is a set experiment. Now we will go on to understand some more terms in probability, and one of them is called events. Events. What is the term events in probability? Events is just any possible outcome. So in the case when you toss a die, you can get only this 1, 2, 3, 4, 5, 6. So you can have an event where you get the outcome 1 or you get the outcome 2 and so on. So event is just possible outcomes. So we define events, it is possible outcomes. Sometimes events they are also called cases. So the possible outcomes are called events. The possible outcomes in a trial. So events sometimes they also call cases. So in this case, when you toss a die, the outcome of getting 1 is an event, outcome of getting 2 is an event, and so on. And then we have this one more definition. What do we mean when we say equally likely events? See, when you toss a die again, the only outcomes that you can get is either 1, 2, 3, 4, 5, or 6. But can you expect that this phase mark 1 will be more likely to come than the other phases? No, right? Because this box is a perfect cube. So when you toss it once like that, you cannot expect any phase to be more likely to come than any other phase. But I'll show you one more example. But if you consider this a matchbox, suppose if you toss this once like that, so you see a matchbox has these two faces, they are bigger in size. So you can expect that these two faces will be more likely to come than these other faces, right? What is the reason? The reason because these two faces, they are bigger, so when you toss like this, it will be more likely to come, showing the top face as these two bigger faces. But here, for this cube, because a die is in the form of a cube, so when you toss this, you cannot predict, or you have no reason to expect any face to come up over any other face, right? That's why all these faces, they are equally likely to come. We don't know, right? So that's why the event of getting 1, 2, 3, 4, 5, or 6, they are equally likely to come. So that is equally likely events. So if you have to define, we'll define this way. The events are said to be equally likely they are said to be equally likely if we cannot expect if they have no reason to expect the preference of any outcome over any other, just like the case of throwing a die. Now, maybe you can have an example for this, tossing or throwing a die. Now we will move on with some important terms, and this one is called exhaustive events. Exhaustive events. When you throw a die, these are the only possible outcomes. You cannot find any more. It will stop only with this number of outcomes. These total number of outcomes, they are called exhaustive events. So this is simple. Exhaustive events means the total number of outcomes. We will move on, and then here we will have this one more term, which is mutually exclusive events. What do we mean when we say mutually exclusive events? Again, let's take the example of tossing a coin. A coin has two faces, and one we call head and the other we call tail. When you toss a coin once, either it will show head or it will show tail, but it can never show both head and tail at the same time, right? So the event of getting head and the event of getting tail, they are said to be mutually exclusive. Why? Because they cannot appear at the same time. So if you have to define mutually exclusive events in general, two or more events are said to be mutually exclusive if they cannot appear at the same time. Sometimes mutually exclusive events, they are also called incompatible events. Now, Before going to the mathematical definition of probability, we have two more terms here, and one of them is called elementary event or simple event. What do we mean when we say elementary or simple event? Elementary event or simple event is just a single event. It's just suppose here, see, when you toss a die, you can get either of these in the top phase. So any single outcome of this is called an elementary event. So the event of getting 1 is an elementary event, and the event of getting 2 is an elementary event. So it's just a single event. And an outcome, and means only one. So an outcome of a random experiment is called an elementary event. Then we will look at one more definition, and that is called compound event. What do we mean when we say compound event? Compound event, suppose again we take the example, when we toss this dice once, then we can either get any of these as the possible outcome. Suppose if I define this event, suppose if I call this event E as the event of getting an odd number. See, when you throw this dice once and you define E to be the event of getting an odd number, then what are the possible outcomes which you are looking for interesting with this one? So it is either 1, 3 or 5. So more than one outcomes will favor this event, right? So this event has more than one possible outcomes. So that event is called a compound event. So in general, if you have to define a compound event, it is an event in which there is more than one possible outcome. See, if you define, suppose a die is tossed once and you define E to be the event of getting an odd number, then what can you say the outcomes which will favor this event? So it is either 1, 3 or 5. So this event has more than one possible outcome. So this type of event is a compound event. Then E is a compound event. Now we will look at the definition of probability. Let me first write down the definition and I will explain after I finish to write. Probability, or the classical definition of probability, here the definition of probability. Suppose in a random experiment we have n exhaustive. Exhaustive means the total number of possible outcomes, and in that random experiment no two outcomes will appear at the same time, and each or all outcomes they are equally likely to happen. Then in such type of random experiment we define probability to be, and suppose we have defined an event A. And from n, m of them are favorable to an event A. Through example, we will understand this meaning of this favorable. Then the probability of the occurrence of A, we denote by PA, is defined as the number of favorable outcomes and divided by the number of exhaustive outcomes. So in other words, we can write this as, because exhaustive means total number of all possible outcomes, so we can write this as, we can also write like this. We can also write this number of exhaustive outcomes as the total number of possible outcomes, because they mean the same. Definition of probability, and here, because the number of favorable outcomes, which means they are favorable to an even A, there are m of them. So in this place I can write m, and the total number of all possible outcomes, there are n of them. So m by n. Let's understand this definition by the help of an example. Again, let's take the example of tossing a die. Suppose when you toss a die once, then how many number of possible outcomes? Suppose, example, let a die be tossed once. Then you can get only these outcomes, right? These are only the possible outcomes. So the possible outcomes are 1, 2, 3, 4, 5, 6. And suppose we have an even A. Suppose the even A is defined like this. Let A be defined as the outcome of getting a number greater than 3, let's say. So here we are looking for an even of getting a number greater than 3. So favorable event which events which are favorable to even A are those events which satisfy with this even A. So in this case, these are all possible outcomes. So from here, what are the outcomes that will satisfy with the definition of even A? Here A is an even of getting a number greater than 3. Here, because greater than 3, so it will either be 4, 5 or 6. These are all favorable to the even A, right? So in this case, how many of them that are favorable to A? There are 1, 2, 3. So in this case, m of them are favorable to get A, and in this case we have m to be 3 of them, 4, 5 and 6. So we'll write down here. So number of favorable outcomes are 3, because there are 3 of them. Then by this definition, the probability for the occurrence of the even A is defined as the number of favorable outcomes by the total number, mean the number of exhaustive outcomes, or the total number of all possible outcomes. So in this case, therefore PA will be So in this case, PA would be the number of favorable outcomes, which is 3, divided by the total number of all possible outcomes. These are the all possible outcomes, and there are 6 of them. So the total number of all possible outcomes is 6, which is 1 by 2. You can put this 3 into 1, 3 into 2. So this is the definition of probability. And before going to the exercise, we will have one more thing to do, and that is called the negative of even A. Here we have this even A. We also have what we mean when we say negative of A. Negative of A, in simple sense, means those events which are not A. Means, so we can write here negative of even, it means not A. Not A is the negative of A. So from here, where we have the total number of all possible outcomes is n, and m of them are favorable to A. So those which are not A are those outcomes which are not favorable to A. So from n, m are favorable to A. M are favorable to A. So those which are not favorable to A, because from n, m of them are favorable to A, so the remaining will be n minus m. So from n minus m of them are not favorable to A. So that is called negative of A. So in the same sense here, not A is a negative of A, and we denote by A bar. So going by this definition, we have PA bar will be number C. A bar means not A. So those outcomes which are not favorable to A. So from n, m are favorable to A. So n minus m, which is left, they are not favorable to A. So in this case will be number of unfavorable cases to A by total number of all possible cases. In this case, number of unfavorable cases is n minus m, and the total is n. We can simplify this. PA bar is equal to, I divide this individually, n by n minus m by n. And before we have that PA to be m by n. So in this case, PA bar n by n is 1 minus m by n. I can use that. So PA, since PA is equal to m by n. In this case, I can take this to the left hand side. It will become PA bar plus PA is equal to 1. So this is very important. We will use this when we do exercise. This is very important. We will use this when we do the exercise. But for today, we will stop here. So until next time, thank you.